having the IP address like 172.16.5.2, and this service is something like external name service. Okay, now in this particular service, let's say you have two pods over here. Okay, and the pods are running Apache. Generally, from any of the pod inside the Kubernetes, okay, let's say you have a running Nginx pod. From this pod, actually, you can resolve, okay, or you can get the IP address of any service in the system. And the syntax for that is you need to run this command, nslookup. First, you will write the namespace name. After that, you will write the service name. After that, .svc, .cluster, .local. Okay. For example, let's say you are writing nslookup. Namespace is, let's say, grass. Service name is, let's say, Manish. .svc, .cluster, .local. So this particular command will actually give you the IP address of the service. Okay. So you do not need to remember the IP addresses of the services. Kubernetes has a facility of an internal DNS. Okay. So you can resolve the service with its name and the namespace. Till here, are you clear, Manish and Nagi?
Yes. Yes.
Manish?
Right. I'm listening.
Clear?
Right.
Like the way you do nslookup on google.com, facebook.com, as the same way you need to do nslookup on the service. Now, what is the use case of this external name? Okay, they are saying that if you want your service to be resolved to a particular name or particular domain, let's say I want my service to be resolved to, let's say the service name is Manish. And I want this service to be resolved as www.google.com or some of my different domain www.kushal.com. Clear? So I will use external name, and in the external name I will write www.google.kushal.com. Now, at the moment when you have like created the external name service, and after that, if you are trying to nslookup from any of the pod, and if you are trying to have the IP address of that particular Manish service, then it actually will be resolved to www.kushal.com, and it will give you the IP address of kushal.com. Just a simple use case, but right now I'm not sure why they are doing it. Clear? So, but how external name works, it is something like that. Clear?
Okay.
I need some more time to dig into it, because right now I'm not clear about why they are giving you external name service. Because I have also asked so many like people, but they are not using external name service. Okay.
Okay.
What is the exact use case of this? For that I need some time, but how it is working, that I have told you. Okay.
Okay.
Clear, Manish? Hello.
Yes. Malaysia, I think.
मनीष हो यहाँ पे? हेलो, म्यूट पे बोल रहे हो क्या? आर यू स्पीकिंग ऑन म्यूट?
No, I'm listening. Question.
Are you clear with this?
Yes.
Do you find any related use case of this?
No. I didn't find any. I checked with one of my friend as well. So they also don't know about this use case, something, this feature.
Yeah, I have also asked so many people. They do not use external name service. But why it is there, I actually need to search. Okay. In the documentation also, they have not given any like useful use case. They are just saying that if you are writing or creating a service of external name, and if anybody from any pod is actually trying to look up for the IP address of the service, it will be resolved to www.kushal.com, which is the external name. But I don't know why. Okay. Now, we were doing what chapter? Fifth, no? Okay, so we have discussed about the cluster IP of service. Okay.
हाँ,
Node
नोड
service.
आईपी हो गया था, हम एक्सटर्नल यूज कर रहे थे, हम यहाँ पे फंसे थे एक्सटर्नल नेम पे.
Yes.
Now we
Load
are-
balancer is something like you need to configure a cloud controller manager. And when you will create a service of load balancer, the service will request the cloud controller manager, and the cloud controller manager will request the cloud service provider to create a load balancer for you. Okay.
Correct, understand. So I think we discussed thoroughly in that use scenario that what exactly the use case in the case of the
See,
external
various
PSP provider.
the various service types allows you to control how to access your services. Some service types may be better suited for your environment, such as load balancer type when deploying in Amazon Web Services, Azure, and Google Compute Engine. With this service type, OpenShift redirects the traffic from the external load balancer to the backend pods. Now see what it is telling. OpenShift redirects the traffic from the external load balancer to the backend pods. It means that OpenShift will directly transfer the traffic from the load balancer to the pods. Now, how the load balancer will be aware about the IP addresses of the pod? So that will be taken by the service. And how the service will be knowing about the pods? So the service has a selector and the pods has the label. Okay. And this can, however, the provider determines the.
Repeat that line. How to redirect the traffic directly from load balancer to the pod?
See, generally service never redirect the traffic to the pod, Manish. Service is just there to give the IP address, okay, to the load balancer. Clear?
Service means जो मेरा service IP है, right? You're saying
Service will never redirect the traffic to the pod. Service only
never
have the information about the IP addresses of the pod with the help of selector.
Service basically service have the information of the IPs of the pods basically.
Yeah. Yes.
Correct?
Yeah.
So it's not. So inbuilt load balancer functionality will do the load balancing of the traffic. Correct?
Yes. Service will not do.
In OpenShift, that functionality is provided by the router functionality, which is a part of the infra node, right? Yes. In OpenShift, is it?
Yes. Route actually ask the service for the IP address of the pod. Then service get the IP address and give those IP address to the route, and after that route directly sends the packet to the pods. Okay. Okay. Service is just to give the IP addresses of the pods, nothing else. Okay. Now, however, the provider determines the load balancing mechanism. This can increase the administration overhead associated with the cluster. Now, the configuration of load balancer is outside the scope of this course, so we are not going to like configure the load balancers. node port type of service we have used, and external name. External name service type is a recent addition. Services that use this service type do not map to selector. Instead, they use DNS names to determine how to access the application that matches the host name. And the control plane creates a CNAME record whose value correspond to the external name. This is a convenient solution for migrating your legacy application to the cluster, as you can run parts of your application outside of the cluster until their migration is complete. So now I need to dig more into it actually. Okay. Now discussing the DNS operator. Now see, when you are writing this nslookup grass.servicename.svc.cluster.local, obviously there must be some DNS server. Yes or no? Can you resolve any IP address without a DNS server? Manish,
No.
Obviously, we need a DNS server. So inside the Kubernetes, you have the DNS server, which is running inside the pod.
Give me 1 minute, Kaushal. Just give me for 1 minute. I was sharing one screen for 1 minute.
Okay, share it.
Can you able to see my screen?
Yes.
So what is that? What is that? We are saying about this one route, right? Router. So where the external traffic comes into the router, and the router will see the services part, look for the services, and
service will get the IP address of the pod.
Correct. So he will get the information from the service and route the traffic to the respective pods as a round robin, right?
Yes.
Okay.
That's the correct one. Okay.
Right. Fine.
Send me this PPT if you can.
No, this is Red Hat PPT. I can't share that PPT. Yeah.
Okay.
Yes.
Now, discussing the DNS operator. So, in the OpenShift, you have an operator which is actually managing the pods of the DNS server. Okay. In the Kubernetes also, let me tell you. In Kubernetes also, you have two pods of core DNS, which are present in the namespace kube system C. Two pods are, and these two pods are running actually on the master node. Okay. So these core DNS pods are responsible to manage the DNS inside the Kubernetes. Okay. Whenever you will like nslookup any service, the request will be going to these pods. Okay. Now, so these two pods are generally managed by the DNS operator inside OpenShift. Okay. So they have created a custom operator for it. Okay. They are saying that creating a default cluster DNS name cluster local means you always need to write cluster.local at the end of the service.
So basically we will run a DNS services as a one of the pod. So which provide me the functionality of the DNS part, right?
Yes, internal DNS.
So we write internal DNS, and we will create a one pod with the operator as a providing by the Red Hat OpenShift as a DNS operator, correct?
Yes.
We will deploy that to one of the pod, right? Or by default it's created, or we have to.
By default it's created.
By default it's created, right?
Assigning a DNS name means backend means a namespace name. Assigning DNS name to service DB. Assigning DNS name to pods DB001 .backend .cluster .local. Okay. Now managing DNS records for service. So they are saying that if you want to find a record for any service, means IPv4 address, then you can write the port name on which the service is running. Port protocol means TCP UDP, SVC, namespace, SVC, cluster.local. For example, let's say if you use a service that exposes the TCP port on 443 to HTTPS, then the SRV record is created as 443_TCP, HTTPS, front end is the service name, .svc, cluster local. If you are trying to nslookup this thing, then it will actually give you the IP address of the front end service. Okay. Now, in the Kubernetes, it is just easy actually. In the OpenShift, you have to mention the port number, protocol, everything actually. Now, after that, this is clear, Manish, Nagy?
That's clear. That's clear.
Yeah.
Introducing the cluster network operator. So see, Manish, you were talking about the
Right.
how
Right,
can I
right, right.
change the CIDR and everything. So this is the
Correct.
part.
Correct. This
You
is the
can
same.
use OC get network cluster, and over here you can change this.
Correct. Right.
Tell
So
me, Manish, what is the CIDR and host prefix?
host prefix and
As you have shown me that file of the Airtel.
Right. So
What is this CIDR and host prefix 23?
let me check.
Like over here, I am giving the range as 14. Over here, I am using 23. What is this?
Host prefix are the same host prefix we're taking as a 23 here as well by default.
But why? What is the use case of this? See,
No, okay.
in your cluster, if I talk about this CIDR 10.128.0.0./14, so how
Right.
many IP addresses you will be having here?
Yes,
26, 2,62,140.
Correct.
Means these are the allocatable IP addresses you can use inside the complete cluster. Okay.
Correct. Understand.
But to limit the IP addresses of the pods, we have used host prefix 23. Means you can only create 512 pods. Okay. So we are actually limiting it. Okay. You cannot create more than 512 pods in the OpenShift cluster. If you want to, you have to change this host prefix. Got it?
Okay. So let's suppose if my this value can be changed in the later stage or we have to ensure that this value should be.
No, that I actually need to make sure. Yeah, today also I was like talking to someone about this. Okay. But he was saying that I think we can, I think, change this value after
on the later stage.
Yes.
Okay.
Okay, but we were discussing that why they have defined the range /14. If we do not need this much IP address, why they have defined the /14? So it obviously means that in the future, if you want to expand your cluster,
correct.
If you want to add more worker nodes, then
Right. We ensure that IP should be. We have taken the same IP. The another subnet will not come, and we cannot add another subnet in that case, right?
Yes.
That is that I understand.
You have used the value 16, I think, yeah, in your file.
Yes, I'm using 16. Yes.
Yeah. Now, and network type is there, so you can choose between OpenShift SDN, OVN, Kubernetes, Courier.
Correct.
Red Hat only supports the
Courier is coming in the sixth. I think when we have using the OpenShift on the top of OpenStack, then this plugin will come in picture. Courier, right? Something, is it?
Yes.
Correct.
But Red Hat only supports.
Normally we are using OpenShift SDN. This is by default SDN provided by the OpenShift, right?
Yes. And one more thing, Manish, that is apart from this course, do you have any idea about NFV?
Presently, I'm working. I think me and Reddy, we are working on the NFV part. Yeah, that's why we are the network function virtualization. We are working.
I need some little bit knowledge about NFV. Okay. If you can like have some time on some Saturday and Sunday, then just tell me.
Sure, man. This is the expertise we have from the last 14 years here. We are working on the NFV part.
Okay, yeah.
I just started from last
Previously we working as a native or a bare metal normal customized hardware. Vendors Ericsson specific hardware. Now it's coming on virtualization. So now Ericsson is doing on created cloud on as a base of OpenStack open source as a CE or Nokia as a CBase. So now I am working as a independent Red Hat OpenStack. So on top of that, the all VNF, NFV are as a workload.
Got it. Okay.
Yeah, this is the
Actually,
very
why
hot.
I need to learn this, because I have some query that the person want to manage the virtual machines with the help of Ansible on this NFV, I think. Okay.
Current understand. So because
Was
this is a very
telling me
hot,
that
hot,
if you have
hot
some
topic
idea
in
about
the
NFV,
market.
then we can try Ansible with it.
Definitely, yes.
Introducing OpenShift network modes. Now, there are generally 3 network modes are there: multi-tenant, subnet, and network policy we have talked about. Okay. By default, it always uses the network policy. Okay. Means if you want to communicate your one pod, okay, to another pod in some another project, then you have to define the network policy. Otherwise, the pods of different projects cannot communicate to each other directly. Okay. But if you want your all the pods in the cluster to be communicable to each other, then you can define the policy as subnet. Okay. And one is multi-tenant.
Sorry. So network policy, if we are using in the SDN as a mode of network policies as a network policy. So if we want to communicate the 2 pods with the different projects, right?
Mm-hmm.
Then
Then you
we
have to define the network policy
define the
inside the project.
policy in the network policy. Okay. And what about the subnet?
In the subnet, all the pods of all the project will be in the flat pod network. They will all communicate with each other. We never use this in the production.
Okay.
Okay.
And multi-tenant?
Multi-tenant means no project pods will be communicable to each other.
No project
Means you cannot make a communication between 2 pods into 2 different projects.
Okay, so so that is a scenario where we commercialize, or we can use as customer CSP providers, so they can use the multi-tenant because they don't want to communicate with in any scenario, right?
But in the multi-tenant, if you want to do communication between different projects, then you will not be able to do it. Okay. If you are using multi-tenant, means it is hard coded. You cannot communicate 2 pods of 2 different projects. But
So
in network policy, by default, the pods will not communicate. But if you are defining a network policy, then they can. Okay.
Got it.
Now, comparing and contrasting network modes. Okay. So subnet mode allows you to create a flat network in which all the pods can communicate with each other across.
Parameter we need to set in the same file which you are showing, right?
Yes.
This mode in the OpenShift
SDN mode configurations. Okay.
Default network mein na.
Now, multi-tenant mode implements segregation at the project level, which provides an extra layer of isolation of pods and services. When using this mode, each project receives a unique VLAN ID that identifies traffic from the pod that belong to the project, and pods are restricted to accessing those pods whose network packet tags use the same VLAN ID. Okay. Pods cannot communicate with pods and services in a different project. Now, in the subnet, all the projects get the VN ID of 0. So if they are having the VN ID of 0, means they all can communicate with each other. Okay. Now, network policy mode provides an extra layer of flexibility by allowing you to define network policies for your pods. By default, without any network policy resource defined, pods in a project can access any other pod. Okay. To isolate one or more pods in a project, define a network policy resource in that project to indicate the allowed ingress and egress connection. See, here is the example. Kind is network policy. API version is this. Name is external access. Now see, pod selector. In the pod selector, we are using a label that app equal to product-catalog, and we are defining an ingress rule. In the ingress rule, we are defining the protocol and the port. Okay. So how to allow external users to access an application with labels matching app::product-catalog over a TCP connection on port 8080. So that you need to define in the project actually.
This thing we are doing when you are giving the lecture on the Kubernetes, when we want to particular application want to use the particular port, so we are defining that part, right? This is a similar thing, right?
Yes.
in Kubernetes we are using the different terminology, and in here we are using the network policy. Is it?
In Kubernetes also you have the concept of network policy. This is not the concept of OpenShift. This is the concept of Kubernetes.
Understand. So example, what one of the use case we are discussing in previously lectures, that if www.amazon.com want to communicate on the 80, but that my pod is running on the host machine where my OS is running on the top of that, right? So my HTTPD service is running on the host level as a 80 port, so we cannot use that. So we need to redirect it to some specific port, right? One of the use case we are discussing. So we need to do some this port level changes on the configuration level, right? See the similar scenario, right? We want to do so we need to do some network policy configuration in the these thing, right?
In the project, okay.
Project, right?
So
This is similar.
let's
This is
say in
similar
project
scenario.
one.
This is similar scenario, right? Right. We need to do this configuration, right?
Yeah, and let's say in the project A, you have created this network policy. Okay. So the traffic will be allowed on port number 8080 if they are matching the labels as app call and product-get log. Okay. Now, one benefit of using network policy is the management of security between projects, which you cannot do with layer 2 technologies such as VLANs. Network policies allows you to create tailored policies between projects to make sure application and users can only access what they should. Clear, Manish? Nagy?
Repeat this line. Sorry, I missed that.
Same. Network policies allows you to create tailored policy between projects to make sure application and users can only access what they should.
Okay, got it.
Introducing
this is very important. Yeah. Right.
Container network interface CNI.
Right.
So as container adoption increases, so does the need to manage the traffic flow between applications. This means having ways of segregating traffic based on policy, performance, and security. One way to segregate and manage this traffic, as you have already told me about Multus, Manish, right? In the previous lecture.
Yes, I heard. I've never worked on that, but I heard from the Red Hat guys, Multus. That's why, and from the senior management guys, because this is very important topic of discussion.
One way to like segregate and manage this traffic flow is to use network function virtualization software. NFVS allows you to control and manage the traffic flow on both the data plane and the control plane. Using NFVS allows you to work with variety of protocols for performance and security reasons. So Multus is an open source project to support multiple network cards in OpenShift. One of the challenges that Multus solves is the migration of network function virtualization to containers. And Multus acts as a broker and the arbiter of other CNI plugins for managing the implementation and lifecycle of the supplementary network devices. It also supports the plugins like Flannel, Celico, and all that.
In NFVA, this is a very important SRIOV.
Yes.
This is very important.
Yes.
You just go to that document. Go to the document.
Document.
The first part, the such as.
SRIOV.
Correct. SR-I, yes, this one.
Okay, so in this, this is my physical NIC card on the hypervisor.
Physical NIC will be communicating directly to the virtual NIC, whatever we created on the which one? On the virtual machine.
We need to enable SRIOV on the NIC.
Right. This setting should be enabled on the BIOS level of the hardware as well.
Yes.
Okay.
In ID rack.
And your ID rack was called to specific to the Dell specific hardware. In HP we call it as ILO, right?
ILO, yes.
So we can say as a BIOS level setting.
Okay, got it.
So because we have to set the number of the virtual function or how many virtual interface we want to create. In HP hardware or Dell hardware, it support maximum per port is equal to 64 virtual NICs or virtual function we call it as.
Okay.
Sure. So we will get in one physical NIC is equal to 64 virtual NICs, and that is mapping. So application, VM or container will use or map their interfaces to that virtual NIC 64 virtual, whatever they want to use. Normally, normal telco application using 10 to 12, 10 to 15 virtual functions.
Virtual NICs.
Virtual NIC, we call it, yes, virtual NICs. So on that virtual NIC has been traffic has segregated and sent through the physical NIC to the outside world.
Okay, got that.
Yes. So this is the, because some of the application, because which is a high throughput application, use that technology because it giving the high throughput, because all the kernel level, these things are bypassed.
Okay, got it.
So
Okay.
basically this functionality is basically provided by the Intel.
Intel.
Yes.
Intel Ethernet with SRIO. Okay.
Correct.
I need to dig into it.
You can, because this is very important topic for the NFVA perspective.
Okay.
And one more is DPDK.
DPDK.
Delhi. Start with D. DPDK. Correct. So data plane development kit.
Okay, got it.
Because in that scenario, some PMD drivers we need to install on that on kernel level, which do the packet processing very fast. So we get the good throughput around, not same like SRIV, but we will get the throughput on the 10 gig card. We get the output around 3 Gbps to 4 Gbps maximum.
Got it.
Yes. So because for that purpose, DPDK, there is that they require the dedicated vCPU to run that PMD drivers.
Okay, got it.
तो इस
एक
पे
दिन मुझे थोड़ा सा बताना इसके बारे में.
हाँ, इसको थोड़ा सा पढ़ लेना. This is very important from the NFVA perspective, because all the VNF using these type of data path only. One is SRIOV and another is DPDK. So how to correlate with the Multus CNI, that want to I learn as well, and you have to dig into that path as well.
Okay, that's great.
How to correlate with the Multus, these two data paths.
Okay, I will.
Yes.
Now, so now one lab is there. So we are logging with a developer user. We are creating a new project. Now we are going into this directory. We have 3 applications. One is a database application, which is a backend application. One is the front-end application. Okay. And one is we have the database backup. Okay. So first we are creating the deployment from this particular file, which will create a backend application. So the MySQL deployment is created, service is created. OC status you can use. Now, if you are seeing the pods, the pod is running over here, MySQL, clear? Now, till it, are you clear?
Yes.
Now, after that, we need to copy this particular database into the pod. So we have copied this particular file from the base machine to this particular pod to this location. After that, we will go inside the pod, and in the pod, we will run MySQL command and we will inject this particular database into the MySQL. And after that, we will use show tables command and it will give me the items. Now exit the container. So we have configured the backend application. Now it has also given me the one more file for the front-end application. So we had created the front-end application, OC get pods, pod is running now. We have created or exposed the service to create a route, clear, and OC get route. So this is my route, and when I'm trying to hit this particular address from my Firefox, it is saying that application is not available. Okay. So let me create a diagram. You have created a service for the front end. Over here, your front end application is running. And one service you have created for the back end. And here your MySQL is running. Okay. For this front end, you have created a route. When you are hitting on the route obviously is going to hit on this particular service or the pod. Now, this particular front end pod is actually not able to communicate to this MySQL pod. Then what could be the error? So what we are going to do first, we are going to SSH into this front end pod, and we are going to check that from this front end app, do we need to communicate to this service? Okay, so let's try that. OC logs front end. We are trying to get the IP addresses of the MySQL service. So this is my MySQL service IP address. Okay, so this is the IP address of my MySQL service. Clear? Now, after that, we are creating a temporary pod from the front end, okay? And we are trying to curl this service. So from this front end app, we are trying to curl this service, and that connection is actually connected, means they are communicating with each other. This communication is proper. Now we are trying to get the IP address of this front end service, and we will try to curl this particular service from the MySQL pod. Okay, we need to check from on the both end. So now I'm having the IP address of the front end service. This is the IP address of my front end service. Now I will go inside this MySQL pod. So OC debug deployment MySQL. I'm creating one pod, and from here I'm trying to curl this service. So see, connection timed out means from this pod, you are not able to communicate to this service. No. So what could be the error? Maybe the service is not able to resolve this particular pod. Possible? So what we need to check? We need to check selector and the label of the pod. Okay. So now OC get pods name equal to front end. Okay. So see, on the pod, you have this particular label, name equal to front end. Okay. Now we need to check the selector. So when we are trying to check the selector on the SVC, the selector is was name equal to API. So I hope you got the error, why it is not able to communicate. So what we need to do, we need to edit the service and we need to change the selector to name from name equal to API to name from front end. Once you will do this, service will have the IP address of the pod and you will be able to communicate with this pod from the MySQL. So we are describing the service deployment. We are editing the service. We are changing the name from name equal to API to name equal to front end. Now you are describing the service. You are having the endpoints. And now you try to access the application. The application is accessible. This is also the one question in the exam actually. Okay. Got it, Manish? Nagy?
Got it.
Yes.
I will do it today or tomorrow maybe. So I will ask the questions. First I will try.
Controlling cluster network ingress. Okay. Now accessing applications from external network. Okay.
लंबा chapter है ये?
No, not chapter number 5.
Sorry?
It is on the chapter number 5. Okay.
So chapter number 5.
Yeah. So what exactly the route is? Let me tell you about route.
This chapter?
What are you saying?
Can we do tomorrow?
Route? Yeah, sure. No issues. In this chapter, we have to discuss about route. This is very big chapter. After that, one lab is given over here. After that, we will be having the 6th chapter. From the 6th chapter, the course will be only for 2 to 3 days actually. Okay.
Okay.
Because these topics are very easy.
And so I think our storage topic is still pending, right? Storage.
We will do that.
Okay. Sure. Right. Can you stop the recording for 2 minutes?
Yes, yes.